Okay, we have here another sample problem. Okay, so we have a continuous beam with an overhang at both ends, no? Okay, so first we're going to do is to determine the fixed end moments. However, for the overhang member, let's say this is A, B, C, D, E, no? So for member AB, that is an overhang, so di na nimo sulbon ang fixed end moments. Okay, kaya you can determine already the exact moment niya at the overhang. Okay, at B. Okay, so if we draw the free body diagram, FBD of AB, okay, so you have this FBD. So you have a concentrated load at the end. This is 10 kilonewtons. The distance is 2 meters. So since you cut it at near at the joint, so naa kay reaction nga vertical and the moment. Okay, so the direction of the moment is to counteract the moment produced by 10 kilonewtons, which is counterclockwise. So you can determine immediately the moment MBA. Ang MAB, wala overhanging end man na siya, so wala siya moment. So MBA is equal to 10 times 2, which is equal to 20 kilonewton meter. Now, since the direction of MBA is clockwise, so manang positive. While at the right end, right overhang, okay, so this is the free body diagram. You have another concentrated load of 8 kilonewtons. Okay, so nakay reaction. And then, ang imong 8 kilonewtons will produce a clockwise moment. So, ang imong reaction diri sa may joint D will be counterclockwise to make this in equilibrium, diba? So this is your this the MDE, no? MDE. So your MDE is equal to 8. Now this is also 2 meters. 8 times 2 equals 16 kilonewton meter. But since the direction of MDE is counterclockwise, so you have to put here negative 16 kilonewton meter. Okay, so we solve for the fixed end moments of each span, no, from support to another support. Okay, so we have FEM BC. FEM BC. Okay, this one, FEM BC. Okay, so FEM BC, you have a concentrated load acting at the midspan. Okay, so this is 2 meters and 2 meters. Okay, the total length is 4 meters. Okay, so my formula, so that is PL over 8. But since sa BC, ang direction sa moment is counterclockwise, so you have a negative sign. Okay, so you have now negative P. So P is 12 and the length is 4 over 8. And this is equal to negative 6 kilonewton meter. Okay, then from CB, okay, so parehas sila pero positive sign, so you have 6 kilonewton meter. And then from CD, so that is a uniformly varying load, so on this side here, that is minus WL squared over 30 equal to minus, ang W is 15, yung span sa member is 6 squared over 30, so this is equal to negative 18 kilonewton meter. And then from DC is minus WL squared over 20. Okay, so this is equal to 15 times 6 squared over 20 was 27 kilonewton meter. Okay, so we solve for our relative stiffness. Okay, so sa overhang end, dili na nimo solbo ng iyang relative stiffness because it seems nga murag sumpay ra man na siya diha. So usa ra ka relative stiffness imong solbon sa member BC ra. And also this one here, ang DA is an overhang. So ang relative stiffness ra sa CD basta na ay overhang. Okay? So KBC equal to KCB equal to I over 4. Okay, and then for KCD, which is equal also to KDC, and that is I over 6. So we find the least common multiple of 4 and 6. So 12, no? So 12 over I. So we multiply this by 12 over I. So this is equal to 3, and this one is equal to 2. Okay, so I have here already a table to learning fill upan. So sa joint B, okay, so sa joint B, you have members BA and BC. Itong imong overhang there is kilid, no? Tanawa na kada joint B. So you have BA and BC. Okay. In joint C, you have CB and CD. Okay, so joint C, you have CB and CD. And joint D, you have DC and DE. Kaning E kay overhanging end naman, so di na nimo siya himuan og joint pod, no? Okay. So ang iyang K for KBC, we have 3, KCB 3, and KDC 2 and 2. Okay. So sa fixed end moments, ang BA na kay moment, diba? So we have already solved that, which is equal to 20. So we have to solve first for the distribution factor. Okay. Now at joint B, kaning BA lagi kay overhang man. So ang gamitan nimo nga distribution factor is only on member BC. Okay. So sa BC, you have a pin. So gi-consider na siya usa ka member. So that is BC over summation of K. So 1 ra gyapon siya, no? So you have 1. And then for CB, so CB is connected to CD. So at joint C, you have 2 members. So this one here is K over summation of K. So 3, summation sa mga K sa joint is 3 plus 2, 5. So this is 3 over 5. And that is equivalent to 0.6. And sa CD, it is 2 over 5 or equal to 0.4. Okay. Here also at D, so overhanging end naman ni siya dire. So 2 over 2. So this is equal to 1. Okay. So again, pero og fixed support gani siya, wa siya distribution factor. This is equal to 0. Okay, so fixed end moments. So sa BA, we have a moment of positive 20. And then for BC, so itong ipasolve diri ganina nga fixed end moment kana, you have BC minus 6. Then for CB equal to 6. What else? CB, CD is negative 18. And then we have 27 and minus 16. Okay, so first you are going to balance, no? Okay, So at joint B, there is a moment of 20 and negative 16. Okay, so they have opposite in sign because positive and minus. So isubtract mo. 20 minus 6 is 14. Now you carry the sign of the bigger value. So ang iyang balance ani is positive 14. Pero kung mo balance ka, negative in sign ang imong hatag, no? So this will be negative 14. Okay. At joint C, excuse me.